Okay, everybody. Hi, I'm Shawn. I think most of you know me. Do me a favor here really quick. If you can hear my voice and you can see that bright orange PowerPoint slide, go ahead and raise your hand in the interface there so I know everything's working all right. Okay, I'm seeing hands being raised. So if you don't hear me or you can't see this, then the problem is probably on your end. So we'll go ahead and get started. Today we are talking about our access points. You can see here my title up there on the screen is maybe a little bit more colorful than the official one that marketing sent out to all of you via email blast. But this is a bit of feedback we've gotten. This webinar today was suggested by one of our other users out there who joined one of our other webinars. This is one of the topics that he suggested. So just keep that in mind. You know, we are looking for your suggestions as to what sort of presentations or trainings you would find beneficial for yourself or your employees. As we go through here today, go ahead and use the Q&A box. So to send in any questions, do not use chat, do not raise your hand, just send them in via Q&A and I will try to answer them as we go along. Way Zoom works here, I've only got so much real estate to be able to see my slides and also see what Zoom is sending me. So Q&A is the best way to reach me. So we'll go ahead and get started here with a brief background on Zyxel for those of you not familiar with us, some of our new partners that have recently joined. The big takeaway here is Zyxel has been making computer networking products now for about 30 years. We started in 1989 in the days of the dial-up bulletin boards and the voice fax data modems. We've got over 100 million devices deployed out in the field and we serve 150 different markets globally. So for some of you that have been here a long time, what started off in the old days as just Zyxel has now split off into separate different companies, all managed by a unifying group known as Zyxel. The most recent change just happened fairly recently, where we have split the channel business from our service provider business. So now there is a Zyxel Networks, which is who I work for, and there is a Zyxel Communications. Who handles the SP side of things. Both of these have offices here in Anaheim, California. So on the channel side of things, these are all the different products we've got: security appliances, wireless solutions, switches, access gateways, various different ways of doing network management. So today we're focusing right here on our wireless solutions. We've got a lot of different access points out there, and it's not always clear to people what the differences may be between them. And then even if you do know the differences, maybe trying to figure out which access point you need. So you've probably seen this either sent to you by our sales team or a similar type of slide during one of our other trainings that we have done. So this is sort of our cheat sheet matrix here to help you try to figure out what the differences are between all these different models. So today we'll sort of break this down and sort of try to help you make sense of what you see on this. So we'll start. So basically we're breaking this down into a couple different areas. We'll talk about build quality, software feature differences, differences in the Wi-Fi technology, differences in antenna technology, differences in management, and differences in form factor. So let's talk about build quality. Basically, it's all the same, whether you're buying our $80 1123 AC V2 or whether you're buying the $600 WAX 650S. All of our access points that we make here aimed at the business space come with a lifetime warranty, and all of them follow the same basic design philosophy. So when we're talking about solid state components or solid state devices, there are two things that generally lead to failure. One of the main causes is something called capacitor failure. Basically, a lot of devices use electrolytic capacitors. So these are basically little tubes of salt water that sit on the board to help us do some stuff there. So we've eliminated those from all of our access point designs. Instead, we've switched over to various solid state capacitors. So there's no worry about them springing a leak, boiling over, or somehow otherwise failing. So that helps us maintain long life on the products, and something you won't find in a lot of the cheaper access points out on the market. The other big cause of failure is over time you get heat fatigue. So we've specifically taken that into design when we're building our access points. So all of our APs, you will find a large metal plate directly behind the PCBA. That is basically a heat sink designed to pull heat off of the board and off of the components on the board. And then we've got a ton of vent holes in most of our designs to vent the heat out. If you look at some of our cheaper competitors out there, they don't have vent holes at all in many of their different models. So you've just got the heat building up inside, which eventually causes the chips or the solder joints to fatigue. And even on the higher end, most of our competitors on the higher end do have proper venting to help get heat out, but most of them don't go to the extra expense of including the heat shield on there to help pull heat out. Some other differences you'll see if you open ours up and you look at some of our competitors. We have more shielding on our PCBA than you'll generally find on any of our competitors. And that's just to help us just that much more with EMI and help us in those tough signal to noise ratio environments. The other big difference is we move the antennas onto their own shielded component that's above the PCBA. Most of our competitors, even Ruckus and stuff, mount their antennas directly onto the PCBA itself. By removing them from the PCBA and putting them on its own separate device there, you get a little extra isolation between the antennas and the board, which helps again with tough signal to noise ratio environments. So when it comes to software, it's all pretty much the same as far as the feature set goes. So, with just 3 tiny exceptions in there. So for mesh, our smart mesh technology, for a long time was not on our Wave 2 access points. It is now there on all of our current access points. The Wi-Fi 6 APs, it'll be lagging behind. It will be coming to them in the future. But at the moment, the Wi-Fi 6 APs do not support mesh. The Wi-Fi health report, which is something that's part of Nebula, is only available on our Wave 2 APs and on our Wi-Fi 6 APs. That's just because the other models, this is a relatively new feature, and the other models just physically can't support the data gathering on top of doing their normal functions. And then WPA3, it's a new encryption level that's part of Wi-Fi 6, so that's only available on Wi-Fi 6 APs. So with the exception of those 3 things, which will soon become 2 things, everything's the same. So you don't need to worry about that when trying to choose your models, worrying that a feature is going to be there or not be there. So when it comes to Wi-Fi technology, we have here, he's got a question in. So Stuart came in and asked a question. Stuart's asking, is mesh something that is turned on or off? So we've got 2 different mesh technologies. The regular mesh, I think it's called Zymesh, is part of our managed mode. So when you're using the APs with a wireless LAN controller, it is a feature in there. And yes, it's a feature that is off entirely unless you turn it on. In fact, it requires a separate one-time license to be able to enable the mesh feature. If you're using Nebula for management, and we've got slides coming up explaining Nebula and stuff like that. If you're using Nebula, there is always a certain level of smart mesh that's enabled, but otherwise it does need to, it's a feature that can be turned on and turned off. So what I mean by that is Nebula APs, if they detect that they have no Ethernet connection, will automatically switch themselves over into a sort of smart mesh mode to try to find another AP that does have a wired connection for it to be able to reach out to the internet and download its config and things like that. However, it is not doing that automatically, or it's not doing that aggressively. So if you enable the smart mesh feature, it then becomes much more aggressive as far as creating an actual mesh and routing traffic over it when needed versus when it's just sort of a backup mode. I hope that answers the question. So on to Wi-Fi technologies, everything we've got today, I mean, you'll still find some old models floating around out there, but basically everything today is either 11AC or it is going to be Wi-Fi 6. So let's talk about that briefly. We get a little bit more into the differences in our dedicated Wireless 101 training, which is more focused on the technology rather than our products. Oops, frozen up here for some reason. Give me a second. So 11AC is what everything is out there. Most of you are probably familiar with that. It has recently been rebranded as Wi-Fi 5 by the Wi-Fi Alliance. There is 11AC Wave 2. So you'll see that called Wi-Fi 5.2. And basically, it's hardware vendors like to get the jump and get product out there as soon as possible. So the first couple generations of chipsets that support 11AC didn't actually support the entire product feature set. So basically the IEEE group comes out, they put together the standard, and what happens is for some of those advanced features, it was going to take a long time to implement those, and there may even been some issues with just waiting for the actual features to be fully defined in the spec. So the chipset vendors started working early on that to support the core functionality, and then added the additional features as part of Wave 2. For the most part, the main thing that's part of Wave 2 that's not part of the Wave 1 that people care about on business APs is something known as MU-MIMO. So it allows your access point to be able to simultaneously transmit data to multiple client devices simultaneously. Generally in Wi-Fi, only one device is able to transmit data at a time. It's only able to transmit that data to one other device. So basically you've got a bunch of peer-to-peer connections. So Wave 2 allowed the AP to be able to create a peer-to-two-peer or peer-to-three-peer connection by reducing overall bandwidth to each individual client and splitting up the data. Again, join our Wi-Fi 101 webinar to learn a little bit more about how that works. And then there's 802.11ax, which is Wi-Fi 6. So that's the new standard that's out there. And again, we're in sort of a situation with Wi-Fi 6 that we were with 802.11ac. A number of the cool features that make Wi-Fi 6 a big change from the previous generations of Wi-Fi are not actually supported by the early Wi-Fi 6 APs. So the chips that could actually support all the full feature set didn't actually get released to the manufacturers until August of last year. So any access point that was launched in August of last year or earlier than that isn't going to support the full Wi-Fi 6 feature set. So something to keep in mind. All of our access points are dual radio, dual band. And then the differences here are going to be spatial streams. And we'll talk a little bit about that. Although again, if you want more in-depth detail on what spatial streams are, Wi-Fi 101 webinar is a good place to start. So for spatial streams, on consumer products, you'll see them advertised as AC 1750, AC 2100, where they take the theoretical maximum speeds between both radios and add them together. On business stuff, you primarily see things advertised by the spatial streams. So basically, spatial streams are how many different streams of data a device can send or receive simultaneously. So if you see a device listed as a 2x2, it tells you it can transmit two different spatial streams simultaneously and also receive two spatial streams simultaneously. 3x3 is telling you it can transmit and receive three different spatial streams. Sometimes you'll see a difference here, such as our Wave 2 APs, where the 5 gigahertz 11AC radio can support a 3x3, so 3 spatial streams, but the 2.4 gigahertz radio can only support 2x2. Something that you'll also see out there, which is really common on Cisco product, is you'll see the 2x2 or 3x3 or 4x4 or whatever. Then you'll see a colon and a number. So what that's telling you is how many antennas they have that can receive or transmit data, the 2x2, 3x3. But the number after the colon is actually how many of those can actually be used at a time. So you'll see a lot of 4x4 colon 3. So it's actually only 3 spatial streams it supports, not the 4x4. It's for the most part, it's a marketing term to try to make it seem faster than it is. So talking a little bit about Wi-Fi 6 in general. Wi-Fi 6 in theory is going to be able to support speeds up to 9.6 gigabits per second. So you'll see it advertised as 10G. It's designed to have higher capacity and work better environments, whether you've got a lot of devices in the area or whether you've got a lot of other access points in the area. There's a bunch of neat technology tricks they do to help use what's called channel reuse. So instead of nearby access points interfering with each other, you can avoid that with Wi-Fi 6 a lot. And then also all of these improvements for Wi-Fi 6 take place in both the 2.4 and the 5 gigahertz spectrum, and will also work in the 6 gigahertz spectrum when that starts to hit the market in another 9 months to a year. So unlike 11N to 11AC, or from Wi-Fi 4 to Wi-Fi 5, all of those improvements in 11AC were only on the 5 gigahertz radio. The 2.4 gigahertz radio, technology-wise, was still 11N. So with 11AC now, or yeah, 11AC with 11AX or Wi-Fi 6, all of those improvements that were made affect both radios this time. So we'll take a look here. This is going through sort of the differences here between 11N, 11AC, and 11AX. The main thing I want to draw your attention to is down here, the data rates. So what you see here is with 11AC, with one spatial stream, the maximum amount of data that you can put through there is a 433 megabits. So this comes into 2 by 2, right? So if it was a 2 by 2, you would have 2 spatial streams. Each theoretically could get up to 433. So those would be called, 900 is what you'd probably see on a data sheet or a website listing for it. 4 by 4, you would take that 433 and multiply it by 4. Same thing goes over here. We're going up to Wi-Fi 6. You can now get 600 megabits on each 80 megahertz wide spatial stream. So again, you would multiply that. So you'd get, with a 2 by 2, you'd get up to 1200 megabits maximum theoretical versus 900 megabits maximum theoretical here. So this is just showing here 11N, the maximum theoretical speed you could get up to was 600 megabits per second, although there's very few devices historically that supported that. 11AC in theory could get up to 6.9 gigabits per second using a lot of spatial streams. And then Wi-Fi 6 is claiming up to 9.6. So you can see here we've got a situation here with a 2 by 2 using 80 megahertz channels. Differences here is 11N was 108 megabits per second. 11AC could get you up to 866 megabits per second. Wi-Fi 6 will get you up to 1.2 gigabits per second. If we take that up and change that to a 4 by 4, maximum speed with 11N was 600. Maximum speed with 11AC is 1.7. Maximum speed here with Wi-Fi 6 is 2.4. So these are the data rates. In real world scenarios, the differences are even greater because of some of those other technologies on the back end, which help with things having to do with interference and supporting multiple devices operating in a small area. So moving on to antenna technology, we've got 3 different technologies. You've got your traditional antenna technology, which is what almost everybody in the industry uses. We have dual optimized antennas, which I think is exclusive to us. I'm sure someone out there can find somebody that I'm overlooking. And then smart antennas, something that we have and Ruckus has, and that's pretty much it out on the market. So this is your traditional antenna pattern. Basically, it's designed under the assumption that your access point is going to be mounted on the ceiling. It then distributes the signal in sort of an upside down umbrella pattern radiating out from that access point. So that's how most of your access points are designed, with this one fixed antenna pattern. What happens is, in a lot of situations, you end up having to mount that access point on a wall because, for one of many reasons, you can't mount it on your customer's ceiling. So unfortunately, that antenna pattern really isn't designed for that. You end up in a situation where a lot of the signal is going up into the ceiling, down into the floor. And then if it's a situation where, it's somebody's cubicle wall or a small office wall, you're not getting a lot of coverage behind the wall over here where you might need some coverage. So one of the ways to work around that is to use dual optimized antennas. So instead of having just one fixed antenna pattern built into the access point, we have put in there 2 different sets of antennas, one optimized for the traditional ceiling mount and one that's optimized for wall mount installation. And then you can pick and choose which one of those you want to use based on where you've installed the access point. So that's dual optimized antenna. And then we've got your smart antenna. So smart antenna has been designed to help focus the beam based on where the clients are in relationship to the access point and where other sources of interference might be in relation to the access point. So instead of having one fixed antenna pattern like a traditional AP, or having two antenna patterns like the dual optimized antenna, you have hundreds and hundreds of patterns that you can choose from. And you can choose from each antenna pattern for each individual client. And this is done in real time. Nothing special is required on the client side of the things. It makes a huge difference in crowded environments. It makes a huge difference when it comes to interference. So a couple of years ago, the University of Brescia, they did their own analysis of smart antenna and non-smart antenna access points. You can see here our coverage was 56% better than Cisco's non-smart antenna APs. And even comparing us to Ruckus, who's the other big vendor when it comes to smart antenna APs, we were able to outperform them by 45% in real world environments. So we'll move on here, talk a little bit about management. We've got a couple options here for you. We have standalone mode, wireless LAN controller mode, and our Nebula cloud. So standalone mode is the traditional way that access points used to get configured, right? You figure out their IP address, you log into it with a web browser or with a SSH, and you configure each of your access points individually. You know, it's fine if you've just got a couple APs, but obviously it's going to be a pain for larger deployments. And if you're also trying to provide management of those APs and push out frequent changes and things like that, it's going to be a real pain. We do have some tools that make standalone mode easier. We have our zone utility or a ZAC utility. This is Windows software that you run on your computer, connect to the network, and it'll help scan the network, find the access points, and make it easy for you to access their GUIs. And it gives you some automated things such as pushing out firmware updates and I believe also some copying of config files to help make it easier for you to push those out. The other long-time way of doing this and the solution for larger deployments has traditionally been a wireless LAN controller. So a wireless LAN controller gives you a piece of hardware on the local network usually, and it handles all management of the access points. So it handles firmware updates, it handles configuration changes, giving you one dedicated device to access to be able to manage all of your access points. And it unlocks some other things here, you know, such as wireless mesh and fast roaming. Now, historically, we've offered dedicated wireless LAN controllers. We still have those, but they are going to be end of life soon. They were supposed to already be phased out, but for some reason they haven't. But going forward, the solution, if you want to provide local management of your access points, is our security series. So all of our different security gateways now, just about all of them have a built-in wireless LAN controller. So if you look here, you'll see two sets of numbers. The first number is how many APs can be managed by the device out of the box for free. And then the other number is how many additional APs can be managed by purchasing one-time licenses to unlock additional capacity. So you'll see that across the board here. So going forward, you won't be using a dedicated wireless LAN controller. You will use one of our security gateways with the wireless LAN controller functionality built into them. And these, if you already have a gateway and you don't want to add a second gateway, these can always be put into bridge mode where they only function as a wireless LAN controller. So then next up, the other option for management is Nebula. So Nebula is a free cloud management platform. Gives you a lot of flexibility and functionality as far as setting up your devices. So to begin with, you don't have to actually take the device out of the box to begin configuration. You can set up your customer site basically before you even order the hardware. Once you receive the hardware, you can use our mobile app to scan the QR code that's on the outside of the box and assign it to your customer's site. And then as soon as that device is eventually plugged in somewhere and gets an internet connection, it will figure out which customer site it's been installed at, and it'll automatically download the configuration for that site. So Seth here says, why is easy mode required for configuration of wireless LAN with the integrated Wi-Fi AP on the firewalls? You know what? I'll be honest with you. I don't know the answer for the question. That would be a question for Marcus or Try. I do not have a lot of experience with configuring APs using the built-in wireless LAN controller on the gateways. Do me a favor, send me an email about that. I'll post my email here. It'll be on the last slide of today's presentation, but it's Shawn R, SHAWNR at Zyxel.com, and I'll follow up with you offline about that. Going back to Nebula now, so you just scan the QR code, and that's pretty much all you need to do. So basically, everything can be up and running in just a few minutes. Even if you don't already have a Nebula account, you can create a Nebula account and do some basic wireless LAN config and even get a guest portal up and running in less than 5 minutes. So to use Nebula, no additional software or hardware is required. So you don't have to buy or download or install any pieces of software. You don't need a cloud key. You don't need a local controller device. You don't need a CNC device. It's all done through the cloud and through a web interface. So anywhere you've got internet access, you have access to all of your customers and all of their sites. And again, we've got dedicated Nebula presentations if you want to learn more about Nebula. So when you're looking at Nebula, there's two main categories. There's Nebula Flex and Nebula Flex Pro. So devices that are labeled Nebula Flex support standalone configuration or cloud-based configuration. Those labeled Nebula Flex Pro, same thing, standalone or Nebula managed, or they work with our controllers, whether it's the standalone or the ones that are built in on the USG. Also, all of the Nebula Flex Pro APs include 1 year of Nebula Professional Pack. So just really quick, Nebula, the core version is free, gets you access to all of the key functionality of your devices, gets you that zero-touch auto deployment, automatic firmware updates, automatic over-the-air config changes, unlimited number of devices, unlimited number of sites, unlimited number of customers that you can manage through the cloud. Professional Pack is primarily aimed at service provider or MSP type functionality. So it gets you a year's worth of logs stored in the cloud. It gets you an audit trail that stores every configuration change and who made that configuration change with a timestamp to help you go back through and troubleshoot things. It gives you automatic push notifications if devices go offline. It has various types of reports that can be generated and then automatically emailed to yourself or to your customer, letting them know what's going on the site, things like that. So you do not need the professional pack. Nebula core version is plenty for most people. But if you need those extra features, you're trying to provide more of an MSP type scenario, Pro Pack is something to look at. And that's available either as an annual license or as a one-time perpetual license. Then form factors. We've got 3 major form factors. We've got your traditional access point form factor, that sort of small circular or square device that mounts up onto the ceiling. We've got a special line of products that handle hospitality. So these are lower powered access points. They still have smart antenna in them. They've got Ethernet pass-through, including a PoE pass-through. So the idea here is in a hospitality scenario, you can have PoE out to power up an IP phone in the room, 2 additional Ethernet ports to connect to, say, the set-top box that's connected to the TV. And then we've got our true outdoor line of products. So these are all IP 6.5 or 6.8, I think, rated, that are designed to handle extreme outdoor environments. These aren't just indoor APs with a plastic closure that has no vent holes to keep water out. These are purpose-built for outdoor and cost quite a bit more because of that. So let's put all of that together. So we'll start here with just a brief overview of some of the different models. So we have our 1100 series, and I guess technically 1300 series access points. So these are all something that can be either used in standalone mode or through Nebula management. We have our mid-tier products here. So these are our 5000 and 6100 series. So these all have either traditional standard antennas or dual optimized antennas, with this one exception here. And these can all be managed standalone through the cloud or with one of our controllers. So just to highlight here, the 5123 AC and the WAC 5302 D-S do not support Nebula. The 5123 AC and the WAC 6103 DI do. So this will be phased out completely here before the end of the year, and this is on its way out as well. Going forward in the future, everything will be Nebula Flex or Nebula Flex Pro. Our higher end models here, these all have smart antenna, or in the case of this one outdoor AP, external antennas for us. So these are our 63, 6500 series access points. And again, all of these are tri-modes or Nebula Flex Pro. And we do have a series of dedicated Nebula access points. So all of these can only be managed with Nebula, and these all include 3 years of Nebula Pro Pack out of the box. These also qualify for a discounted lifetime. So if you know you want the perpetual license, it's cheaper than if you were using it on some of the other models. And then we've got our Wi-Fi 6 APs. This bad boy here, the WAC 650S, this is the only one that's available today. The rest of these, though, are coming soon. We'll have limited quantities of the NWA 110AX and the WAC 610D in distribution, hopefully in June. And then these other two models will be probably August, although we're trying to still get them in sooner. The WAC 610D and the NWA 110AX, these are both available today in Europe and probably most of the rest of the world. FCC certification takes a little extra time, and unfortunately, the COVID situation really screwed up getting these certified. So that's why these have been delayed here in North America. So let's go through here and just sort of try to put this all together. So we've got these 3 models of AP. You look at the photo there, it's the same photo. They look exactly the same. So what is the difference between them? So we'll pull up here our cross-reference sheet. So here's the NAP 102. Here is the NWA 1123 ACV2. The 5123 AC has been left off this chart just because the text would be ridiculously small to fit everything on there. So we chose to leave a couple models off. But you can sort of use this here to quickly see what the differences are. You see here a free version of Nebula versus 3 years of Pro Pack, and management. The NAP 102 can only be managed with Nebula, whereas the 1123 has Nebula or Standalone. So basically everything is exactly the same except for how they are managed. That's the difference between these 3 models. Oops. And now we'll do these guys here. So NWA 1123 ACHD, the 5123 ACHD, and the WAC 6303D-S. What is the difference? So we go back here, all 3 of them are on the comparison sheet this time. So basically the differences here are going to be antenna technology and management. So by going from the 1123 up to the 5123, you get controller-based management, and you get 1 year of Pro Pack thrown in with the Nebula Flex Pro. If you go from the 5123 AC up to the WAC 6303 D-S, it's the same as the 5123. The only thing that's changing is the antenna. This gets you that smart antenna technology. So when you're trying to figure out which access point you need, some questions here for you to ask yourself. Where are these being mounted? Both physically, is it on the ceiling? Is it on the wall? But also, what's the use case scenario here for you? Is this going to be in like a conference center where you might have hundreds of people in a small space? Is this going into a classroom where you have 30 or 40 students all using a Chromebook? Or is this going in a traditional office where you have a couple dozen users, that type of thing. So that'll help you figure out, do you need traditional ceiling mount? Do you need smart antenna or dual optimized antenna, or is traditional antenna fine? Do you need the heavy duty outdoor design? And then just ask yourself, how are you planning to manage these? Is this just a one-time install of a few APs, or do you need some sort of centralized management? And then do you want it locally managed, or do you want it managed through the cloud? And then just ask, how many users are expected to connect to this access point? That'll let you know if you need the smart antenna technology. Smart antenna makes a huge difference when you've got a lot of users in a small area, or you've got a lot of access points in a relatively small area. I know even in cases where it's just like a small office, but it's a small office in a larger apartment or a larger office building where your neighbors, you have no control over their network. Smart antenna helps a lot with that, just because of the interference, dealing with that interference that might be coming from your neighbors, even though you don't have it yourself. And then that'll also help you figure out, do you want Wi-Fi 6? If you've got a lot of users, Wi-Fi 6 gives you a lot of benefits. Do you need the faster speeds? So that is it for today's webinar. I see I've got some Q&A questions here, which I'll get to in just a second. So if you do have some questions for me, go ahead and throw them into the Q&A interface. My email is up there right here on the screen for you, ShawnR@Zyxel.com, SHAWNR. Let me know, this is the first time doing this presentation. Let me know how it went. If you have any ideas for how to make it better, things you felt I glossed over that I should have spent more time on, etc., go ahead and email me offline there. You can also send me any sort of offline questions there. And then I do also want to highlight the fact we do have a user forum that's available at forum.zyxel.com. It is split into consumer, business, and Nebula. And unlike a lot of our competition, this board is actually monitored by our product management and R&D teams in Taiwan at our headquarters, and they do weigh in and post things there and respond to questions. They also post all sorts of guides and things like that, feature enhancements, letting you know what's going on. So it's a good place to log into. And if you've got feature suggestions, things like that, it's a great way to get them in front of those guys, or to answer questions that don't need immediate response. Okay, so let's start with questions now. Again, send them in with the Q&A box. I've got a question here from Adam. So Adam is asking here, how well do the 11AC AX APs handle bridge plus AP configuration? So those all handle them just fine. You cannot do that with Nebula, so if you are doing it that way, you do need either standalone mode or controller mode, but we absolutely can do that. It works just fine. If you're looking to do more of a mesh type situation where you want multiple paths in case one of them goes offline, you can use the smart mesh or the wireless LAN controller to do that. Or excuse me, the Zymesh with the wireless LAN controller, or smart mesh. Smart mesh on Nebula does not at the moment do pass through. So the AP can work as both a bridge and an AP, but it will not send additional data out over the Ethernet port. See, if you want to, use it to create a bridge, act as an AP, but also have traffic going to additional switches or devices locally, the Nebula Smart Mesh does not currently support that. Dave is asking, what security concerns are there with using Nebula? So not a whole heck of a lot. So we get into this a little bit more on the actual dedicated Nebula presentation. But we are compliant with HIPAA, PCI, and everything like that with the Nebula Cloud. Nebula Cloud is just there for management, pushing out configuration changes, things like that. So none of the user data goes into our cloud. So there's no risk of user information leaking, credit card information leaking, because none of that goes into our cloud interface. Our cloud interface is purely an out-of-band management solution. Yeah, so that's what we've got as far as that goes. It doesn't make any other changes as far as your wireless LAN security goes, the safety of pre-shared keys, things like that. The cloud itself is hosted in Amazon AWS, which is probably, I believe, the #1 cloud platform out there. So you don't have to worry about security from that side of things. Seth has another question here. So does the WAC 6303 D-S have Wave 2? So yes, it is a Wave 2 access point. So the NWA 1123 ACHD, the 5123 ACHD, and the WAC 6303 D-S, those are our 3 Wave 2 access points. What is the ERP for the new Wi-Fi 6 access point? Is ERP the reference price? So the one we have right now, the WAC 650S, I think that's somewhere in the ballpark. Your price, probably through distribution, is probably somewhere in the neighborhood of 650-ish. You'd want to check with them. But coming forward, everything's going to be a lot cheaper. We should have some Wi-Fi 6 stuff starting at about $200 and going up from there. So anywhere between 200 and 650 or so. Adam's also asking if we offer NFR devices. So the answer to that is yes, we do. So reach out to your salesperson. You do need to be part of our partner program and qualified to be that part of that. And then Jacob or Ivan can get you hooked up with an NFR. Some of our lower end devices we don't, but most of our business class stuff all has NFR as an available option. Stuart has another questions here. Can different SSIDs be configured for different VLANs? Yes, so by default, each SSID should be on its own VLAN, so we do support that. I believe we just recently added the ability on Nebula, and we've always had this ability with the wireless LAN controller to use 802.1x to assign VLANs on a per user basis. And then coming up here with the next major Nebula update, which is going to be free and probably let's call it beginning of July. That's going to allow us to use one SSID with multiple PSKs, and then the PSK will determine which VLAN the user gets put on. So you can have one SSID instead of multiple, and the sales guys can have one PSK, the admin team can have another PSK, guest users can have another PSK. And that'll support up to 1,000 different PSKs. So you can do it on a per user basis also if you'd rather do things that way. And again, when they authenticate, they will be assigned their VLAN based on which PSK is used. So that is it for questions. If you have some more, feel free to send them in. But again, my email's up there on the screen. Feel free to email me directly for any sort of questions. I know there was that one question earlier about configuring the wireless LAN. When using the security gateways and being forced to use easy mode. So go ahead and email me that because I don't have your contact information and I will get you the answer there for that. If you are typing something up, go ahead, do me a favor, pause, highlight it, copy it, and send it to me in an email because I'm gonna go ahead and end today's webinar. Thank you everyone for turning out. And again, email me any suggestions for topics you have or any feedback on today's webinar. How to improve it, how to make it better, things I screwed up, things I did good, let me know. Thanks, guys.